Welcome everyone to the second Presto Community Meeting. So just a reminder, this meeting is being recorded, so anyone that missed it can see it later. Just a few updates before we start. So in the past 3 or 4 weeks, we've done about 3 releases. There's the next one coming out today, that's 3 or 4. There's a couple of major bug fixes, so if you're following the releases, please update. And we'll post on the releases channel when it's done later today. There are some recent changes that went in the past few releases and in the current one, such as cost-based. So there's an improvement for the cost-based optimizer to support semi-joins. There's a new Elasticsearch connector that went in a couple releases ago. There's a spherical geography type. So if you use geospatial functions, this might be relevant to you. It's useful for computing distances and areas on the surface of the Earth instead of on a plane. In approximation of the Earth, it's a sphere specifically, instead of on a plane, so you get more accurate results. And another major one is support for Google Cloud Storage that went in a couple of releases ago too. And it supports the authentication scheme that Google Cloud Storage supports. So there's a couple of things to be aware of that are going on. So David, can you talk about the performance?
Yeah, so I've been working on upgrading Presto to use the Hive 3.1 library code. And in there, they've changed how timestamps and other things work. And so that makes it problematic to support the legacy writers for RC file and ORC, and also difficult to support the dwarf file format. So we're proposing to remove those. We've always intended to get rid of them because they're legacy and they've been disabled by default for quite a while. So if anyone is still using those, please let us know or post on the Slack channel.
Yeah,
so the other project that's been ongoing for a while is around timestamp and timestamp semantics. When I added timestamps like 5 years ago, I did it wrong, and there's some changes we're going to have to do in the engine. This should be transparent to most users, with one exception. If you are running a system where you have clients using multiple client-side time zones, there's going to be some impact for you. So please reach out on the timestamps channel on Slack or message me directly, and let's talk about it. So if you specifically have clients running in different time zones, that's where you would run into issues.
And as Piotr mentioned in the chat, anyone that writes connectors, custom connectors, should also get involved because it will affect you. Okay, so we run a poll on the Slack channel and to see what people want to talk about today. And based on the results, there are 2 topics that came up at the top. One is supporting more complex pushdown into connectors and coordinated HA. So we're going to talk about start talking about the first one, and if we have time, we'll get into the second one. I don't know how the meeting is going to go. Depends on how many questions, how interactive it becomes, and we'll see. If we don't have time for the second one, we'll cover it next time.
If you have questions throughout this, just ask on the chat, and we may or may not, depending on the complexity, want you to jump in with video or audio to clarify.
Yeah, we have fewer people today, so it should be a bit easier to have people jump in.
Yeah.
Okay. Let me
share this.
Let me share. Yeah, I have some slides here to make it easier to guide the discussion. Okay, can everyone see that screen?
So I'll give a thumbs up on
the chat.
If you're seeing complex operation pushdown. Anyone?
Okay, perfect.
Awesome.
All right, so first I wanted to give a little bit of background of what Presto supports today and some of the history. So we initially added the ability to push down some predicates to connectors to be able to support partition pruning for Hive. So the idea is that with Hive, you have data organized in partitions, and the value of some of the columns is known for all the rows in those partitions. So if we can take advantage of those values, we can maybe filter entire partitions ahead of time before the query even starts. So when we added support for that, we said, okay, given what Hive allows, simple range predicates seem reasonable to support, whether things are null or not. We can also do that. So we end up modeling expressions over those expressions that simulate ranges and nullability checks as what we call tuple domain. You may have seen that in the code. This very simply is a conjunction of range queries over each column. So you can see an example there. You have column 0 between two values or between two other values and so on, and some other column between two values or and so on. Now this is very simple, very simplistic. It doesn't support, it supports only very basic things people might want to do. So if you have a query that says where, I know, date or DS equals some value, it will be able to filter it. But if you do something like where
A like B.
Yeah, A like B, or even say cast of some value as date equals something, and the value is a partition column, it wouldn't work. So we added another facility for that, which is it's a way for the connectors to sort of evaluate those more complex expressions by filling in the values of columns they know. So you can think of, you take an expression, you fill in with, let's say, here's an example at the bottom. Let's say you have an expression that is A equals 1 and B equals 2. And let's say A is a partition key. If you know A, you can fill it in, and then you can simplify or constant fold that expression, and it will give you some answer. The answer will be either true, false, null, or it will be another expression, because you can simplify all the way. So the engine can use that, or the connector can use that information to decide whether all the values in a partition are gonna return false or null, and then discard that entire partition. And in that case, in this example, you can see if we say A equals 0, then the A equals 1 term evaluates to false, so the entire expression evaluates to false, and there's it doesn't matter what the value of B is, no rows in that partition will match, so the connector can discard that. If A equals 1, then the first term evaluates to true, and we can't tell anything else unless we know the value of B. So in that case, the connector cannot make have a definitive answer of whether that partition, rows in that partition match or not. So it has to include the rows in the execution. So this helps in some cases. It helps with more complex expressions, like I was saying, when you have cast of the partition column as some value and you're comparing that. But it doesn't allow the connector to further inspect the expression or to do some manipulation to do more complex decisions. So this is where we are right now. So we've been talking to a lot of people over the past few months, and what people have said is they want to be able to push more complex filters. Like, for example, you have a like expression. You want to be able to push that into the connector, because some connectors understand like expressions, or understand even regular expressions. So you want to be able to take advantage of that. I think Elasticsearch is a case of that, where if you knew the expression, you could maybe filter a bunch of data up front. There's other types of operations that people want to be able to push down, like dereference expressions. When we have a row type, you say A.B or something like that, or an array or a map. Those are expressions that for some formats, you can push down all the way into the format. For example, in Parquet, columns or rows are decomposed into the individual fields. So if you know that you're accessing A.X and just A.X, and you also have fields a Y and Z, you don't need to produce Y and Z if you can push down the entire A.X to the connector. There's a big use case for aggregations, pushing down aggregations. There's systems that pre-aggregate data, and being able to push down aggregations allows the connectors to produce the pre-aggregates and let Presto deal with the rest of the query execution. Like, this could be a big saving in computation. And although we haven't heard about it, being able to push down joins could be useful. This could, in particular, could be useful for connectors like the JDBC-based connectors like MySQL, Postgres, etc. Which, if you have a query that involves tables entirely in one of the connectors, then you could potentially push down an entire subquery into the connector. So Piotr is saying that
people ask for that a lot.
People actually ask for that. Okay, that's good to know then. There's another scenario which is kind of the dual of the pushdown, is being able to push or provide additional filters or push things up from the connectors into the engine as the query gets planned. For example, by pulling filters, we can simulate row-level filtering. So based on the authorization of the user, the connector could provide additional filters that get injected into the query and be able to filter rows that the user shouldn't be able to see. Also, for example, if we can have connectors provide transformations like some kind of projections of the values that come out of the table based on the user that is querying the table, it is possible to do things like masking values that are sensitive, or just like even like telephone numbers, or removing certain values like social security numbers, etc. This allows the connector to decide what kind of masking or projection needs to be done. So those are kind of the goals. There's a long-term approach, which we've talked about for a while. This is something that eventually we'll get to, but we don't want to have to sequence this set of features that seem to be very important for people behind this other this approach, which is basically revamping the IR and exposing it to connectors. Right now, it's not in a shape that where we can commit to maintaining backwards compatibility. There's issues with because of class loader isolation between connectors. We can't expose certain things into the connectors and so on. So we basically need to revamp the IR before we can do that, but we don't want to have this feature way behind that. So we're taking a different approach in the short term, which should be easy to retrofit into this longer term approach when the time comes.
Explain what IR is.
That's the intermediate representation of the plan. Right now, if you look at the code, it's the plan node and all the children of that in the hierarchy. The IR is a standard term in compilers. All right. So what's the short-term approach?
Did you miss the rest of the points?
Yeah, that's just for people to read. I mean, you don't need to talk about that. Okay. I mean, the important part is what we're going to talk about now. So the short-term approach is basically is leveraging what we have today and adding just a few more incremental changes to make the whole thing work. So before we get into that, let me do a recap of how the optimizer works, or how one of the parts of the optimizer works. We have like 3 generations of the optimizer inside of Presto right now. So the idea is you have a plan, and well, I don't think you guys can. You guys see the arrow as the cursor as I move it, so I can point?
Yes, we can.
Okay, awesome. So let's say we start with some plan. We have a plan has a set of nodes, and the optimizer, and there's a set of rules that know how to transform combinations of those nodes into some other combinations. So what the optimizer does is it it iterates over all the rules and all the nodes and tries to apply all the transformations it can. This is in a way, it's a greedy optimization without any concerns about what is something good or bad, or is going to get stuck in a local optima or something like that. Now there are some rules that can take into account cost, and we do that for join type selection and ordering. But basically what happens is the optimizer looks at one rule to say we have rules here that says I'm gonna match a combination of a B over a C, and then I'm gonna transform it. So it matches that and it swaps the B and the C with another variant. Let's say in this case it pushed B below C, right? So it just splices that into the existing plan. Then it continues with the next rule and says, okay, I can match a B over a D and transform it. So you can see some variant of a B over a D here. So it transforms into another thing. So you could think of that as pushing down something into the bottom operator.
So
right?
an example of a rule that works like this is limit pushdown. So if B is a limit, it will get pushed down if possible below, let's say C is a projection. And then if B and D are both limits, the system will go and say, oh, well, what I can do is choose the minimum limit and then squash that into a new operator, right, as an example.
So the advantage of this approach is that you can write rules that are they are targeted. You don't need to. So in the older version of the transformations, which you can see they're visitor based. Each visitor needs to understand every possible type of node, and it needs to know how to apply that optimization to every type of node. With this approach of having rules and having the optimizer drive the execution and matching and application of the rules, you can write targeted rules that are only concerned about the local combination of the operations or the nodes. So the idea with, how we're going to tackle pushdown is basically build on top of that. And I here have an example how to do it with filters, but the same thing applies for aggregations, joins, and so on. So basic idea is we have a rule that matches a filter on top of a table scan, and that can and that rule can transform that into another combination of a filter on top of a modified table scan. So what goes in that table scan is the result of taking the filter and pushing it into the connector. So it's up to the connector to decide how to apply that filter into how to consider that filter in the table scan and come back with a new, if you will, a new virtual table that includes that that filter. And then for any filter that you didn't understand, it will end up on top of the table scan, and the engine will process that. So the rule will talk to a new metadata API. We haven't added that yet. That says, okay, I match the filter on top of a table scan. Metadata, try to apply this filter on top of that of the table handle associated with the table scan, and give me, if you can, give me a new table handle and a new filter of anything that you can process. The metadata layer, based on the table handle that was passed in, dispatches to the right connector, and then the connector takes care of subsuming that filter if it can. So very simple. Same thing applies to projections. We can, if you go look at the document, there's a couple of examples how that would work. So the plan, how we're approaching this. Is someone asking a question?
Yep. Please go ahead, ask your question. Michael.
We can barely hear you if
yeah,
you're talking.
Now, do you hear me now?
No.
No.
Hold on. I think I need to change the microphone settings.
Okay. That seemed louder, whoever that was.
Okay, do you hear now? Sorry.
Yes.
Yeah, it's
Okay,
better.
so you were saying about projection pushdown. Does it require intermediate representation to be implemented?
So, well, let me backtrack a bit here. So we know we need to, for every type of operation we're going to push down, like filters, projections, etc., we need some way of representing them and passing them into the metadata. And so we're not going to revamp the entire IR before we can do that, but we're going to come up with a simplified way to represent those filters and projections and even aggregation expressions that is not dependent on the existing plan node and AST and syntax tree expression language. This is because we don't want to expose connectors to those parts of the system and all the dependencies. And this is due to class loader isolation and class conflicts and so on. So yeah, we are going to introduce some limited form of an expression language that we can communicate into connectors. And actually that's listed here. Yeah, I have it here. So let me go over the what the plan is, how we're thinking about it, and then if I still haven't answered the question, then then I can answer that. So there's a document I've been writing, so please take a look at it if you want all the details. I'm going to keep adding to it over the next few days. Basically, there's a couple of things we need to take care of before we can start making changes. One is to clean up how we're dealing with table layouts and all the machinery around that. This is it's something that gets in the way of being able to push this down these things. I'm not going to talk much about what table layouts are and so on. So if you're familiar, you probably understand what I'm talking about, but otherwise don't worry too much. The basic thing I wanted to say is like there's some prerequisites that we're taking care of, and once we have that, then we can start building the integration with the new APIs and the new rules. So the one thing that's still pending is defining that simple language, and it may be just a simple variant of what we have today for expressions. It may be derived from what we have in the system called row expression, which was originally intended to be something like this. This is still to be determined. So, okay, someone's asking questions again. Yes, Praveen, so we're not going to be using tuple domain. The idea is to have a more powerful expression language. Tuple domain is very limited, and it was just you can think of it as a simplified expression language only for range expressions, but it's not powerful enough for anything else. And trying to extend it for anything else is way too complicated, and I think it's going to be harder than defining something separate and then eventually throwing tuple domain away.
I have a question. Do you, Martin, know the set of features this language needs to have in the phase 1 of the feature development?
I mean, there's a set of basic features, like it has to represent constants, it has to represent function calls, and
a couple other
and
Boolean operators like and or.
Those are represented as functions in the engine. So connectors will have to have an understanding of this function represents an and expression or something like that.
Okay.
Yeah.
But there are more complex structures like case statements and things like that that will probably need special handling, like they do today.
If possible. Yeah. Right. So the next step, once we have that defined, is to build all the pairs of rules and APIs in the metadata layer. So this is push aggregation into connector plus the rule that can do that, or push join into connector and the rule that does it, and so on. This is a point where we can probably parallelize development if people are interested in helping. And then combined with that, as we start adding those rules and metadata APIs, integrating that into connectors. Like for example, for Hive, being able to push dereference expressions and array subscript and so on into Parquet or Orc. That's something that can be done in parallel. For MySQL, Postgres connectors, etc., being able to push down those entire operations into the connectors. So this is again another place where if people want to get involved, it's a good good place to help. And then once we're done with all the integrations and there's no more dependencies on the old table layout, functions and behaviors, we can remove all that machinery and simplify the whole thing. This is, and then in the future when we have the revamped IR and the optimizer that can consider multiple plans and all that, this is something that can be easily folded into that system by having a set of, you can think of a toolkit of rules that connectors can use to, instead of implementing these APIs of push, join into connector, push aggregation into connector, you can just provide a rule that does it for them, but leverages all the behavior they had implemented in the beginning. So this is something that we can walk our way into instead of having to wait until everything's done. So that's pretty much, and there's more details on that wiki if you haven't seen it. Just go to the wiki on the Presto SQL, Presto repo and find the document. There's an issue where we're tracking the work that's going to be required. I plan to put up this set of items in that issue so we can start tracking the work items and assign work to people if they're interested. So I'm also going to create a channel so we can have more high bandwidth discussions as we keep working on this. So anyone that's interested, you can join that. I'll post on the Slack channel when I do. So any thoughts, questions, anything you think we're missing in the current thinking? No? Anyone interested in helping with this? I know of there's Senjao and Lu that and Praveen have expressed interest in helping with some of these things. So if there's other people, like, let me know. Okay. Right. So yeah, about half an hour still. So let's go talk about the next thing then.
Cool.
You want to start?
Yeah. Although I don't think anyone can actually see us because we're sharing the slides.
Oh, you can see the picture in picture.
All right. Cool. So I'm going to talk about.
Hold on, there's a question there. In terms of user-defined rules, so we're not going to have user-defined rules right now. Like if you're saying user-defined as connector-defined rules, that's not the short-term approach. Like I guess you could think of these metadata APIs that say push something to connector, push join, push aggregation, etc. Those are the set of rules that are supported. In the future, once we revamp the IR and are able to expose the IR and the rule framework to connectors, then connectors will be able to write custom rules for any operation. So the hope is that the set of operations we're implementing right now is sufficient to cover the majority case.
I can comment on user-defined rules. It's very easy to expose this on the connector level, provided that there is some plan representation, but doesn't really solve the problem, because today the rules have some dependencies between each other, and the ordering how the optimization is done is not really something opaque. It's not really random. It's unfortunately well crafted, or maybe crafted, but maybe not well. So the order of optimization does matter. And when we were to expose, allow the connector to provide rules, we would pick a random place in an optimization order when the connector rules would be inserted, and it would solve some problems, but some problems wouldn't solve. So actually, I think the approach that Martin presented is good because it delivers on the promise without providing a toolkit that solves some cases and doesn't deliver.
Yes, and to Piotr's point, once like the thing that we need to be able to support that is the enhanced memo structure that can consider multiple plans at the same time, so that basically all the possible transformations are being considered, all the possible plans that are results of transformations are being considered, and you don't end up, so the order in which you apply the rules doesn't matter, because you're looking at every possible plan, and you don't get stuck in a local optimum. For example,
You also have the problem of lack of convergence, where they don't actually converge, so you actually iterate.
That's yeah. You could. It's very easy right now to add a rule that undoes what another rule does, and then you end up with this ping pong where the optimizer says, "Oh, I'm going to apply this one. Oh, now I can apply the other one. Oh, now I can apply the first one again," and you never finish. What Piotr was talking about, you have, I know, a rule that knows how to turn a union or one of the high-level set operations into a combination of lower-level operations like aggregations with joins, etc. If you apply that rule before other optimizations, you may not be able to later apply optimizations that understand fundamentally what a union or accept or something like that does. So you end up with suboptimal plans. And that's a challenge, is how to make that work in the scenario where connectors can provide arbitrary rules where the ordering and where they execute is not defined. Right? Let's move on to the next one.
You can always ask questions at the end also. So I'm going to talk about coordinator HA. So this is one of the very popular topics when we go out and talk to people. And it's something that we started working on a couple months back. But what we're, so much like the Pushdown stuff, this is a long-term plan. So I'm going to talk about like the first step of how we get to the point where we can put in a better HA system. And so the first step is a dispatcher. So today, this picture is a super simplified picture of what a Presto cluster looks like. So a client talks to a coordinator, sends a query. The query gets put into a queue, and there's queuing rules, etc. And at some point, that query is selected for execution. That same process starts executing the query, handles coordination with a big cloud of workers, and feeds the results back to the client. So the job of the coordinator is multiple jobs today. So it does all of the resource queuing before things get involved in execution. It coordinates the execution of a handful of queries. And it also does things like track resource usage on workers. It manages the UI and a bunch of other stuff like that. So today, if you have a fault in a worker, you lose all the queries that happen to have been running on that worker, okay? They all fail. If you have a fault in your coordinator, it's a much bigger impact, because not only do you lose literally all of the executing queries, plus you lose every query that had been submitted and hasn't actually started executing. So the impact is quite big. To mitigate that, we typically try to do as little work as possible in the coordinator so that it has lots of extra resources so that it isn't going to crash from like resource oversubscription. But I mean, it still runs on hardware, and hardware can crash, or, you know, and someone can accidentally go in and run kill 9 and kill all your processes or something like that. So the first step that we're going to talk about that we're looking at doing is to split the coordinator's responsibilities in half. So, and this shows the picture of the very first step, the stuff that I've been working on. So what we end up doing is we pull out of coordinators into a process we're calling the dispatcher. We pull out the queuing, the resource management, and the UI. And that means that each coordinator is only handling coordination of the execution of the queries that are actually executing right now. So each one would handle, I don't know, 20 queries or maybe 100 if you're a fairly highly concurrent system. And so in this model, and then the idea is that you would have multiple clusters, which works for bigger installations. And you would have, so each cluster would have a single coordinator and a handful of workers associated with it. So this changes the fault model so that you still have, if a worker crashes, you lose the queries executing on that workers. If a coordinator crashes, you only lose the queries that it is actually coordinating at that point. You don't lose your queues. Now, if the dispatcher crashes, you're going to lose the queue, but you don't actually lose the queries that are currently executing because the clients talk directly to the coordinator. So you're basically creating smaller fault domains for this. And we're doing this model because typically people want to have multiple clusters because it makes upgrading easier. Because when you upgrade a Presto cluster today, your coordinator and your workers actually have to be the same version. And therefore, you typically, what you do is you have two clusters. You take one offline, you upgrade it, you bring it back online, you take the other one offline. So this is the first step. And so this is getting us to the point where we're splitting apart that fault domain. And again, in this case, now the dispatcher is doing even less work. So the thing that holds all the queues is doing even less work. It's not even coordinating queries. And it's basically just super simple. It's just moving data around in memory. It's moving, you know, objects around in memory. So it is unlikely to cross from software faults, really only hardware faults at that point. The next step after this is supporting multiple coordinators in a single cluster. So in this case, it looks very similar to the previous one, but you have in your single cluster, you would have coordinators A and B, and the dispatcher would balance the load across the different coordinators, further reducing the impact of any crash to a single coordinator. Also allows the coordinators to do a lot more work in like query planning, do more resource intensive stuff. And so the idea would be that you would have a number of these. And so if you crash, you're only going to lose like a handful of queries. What is this question? Can we embed the dispatcher? So I didn't mention this. So to answer Praveen's question, this model where you have a single process doing all the work will always be supported for smaller installations because you just typically don't have enough machines to run all that stuff. If you're in a cloud environment though, you probably want to pull the dispatcher out into like some small machine since it isn't going to need a lot of resources. Hope that answered Praveen's question. All right, so and then the final step will be the combination of all these. So you'll have a sorry, not the final step, once we have the multiple coordinators in a cluster and we have the multiple cluster support, those are complementary. So you'll be able to use both of them at the same time. After we have that all working, the last step is to make the queue inside the dispatcher be resilient. The other piece is the UI and the resource management. That's all actually built on the fly based on real world measurements out of the clusters. So it's really only the queue that contains stateful information, and we'll need a way to persist that into a highly available store and share it across multiple dispatchers and do some coordination across the dispatchers to make sure that only one of them is making a decision at a time, but not super complicated after that. Actually splitting the dispatching out of the coordination is a pretty complex process due to the asynchronous nature of Presto. So that's the really high level plan. Did I miss anything?
Well,
There's a question there.
Making the queue resilient is independent from multiple coordinators, so we could actually do that first if people need it.
That is true. Yes. Yes, absolutely. Yeah, that's an orthogonal. Yeah, good point.
So there's two questions there.
Yeah. Embed.
Where does discovery go?
So discovery discovery has to be there has to be like one in each cluster to begin with. So sorry, what? Oh, sorry. Oh, there we go. So the way discovery works, each cluster needs to have its own independent discovery. So the coordinator and worker discover each other through discovery. So the question is, how does the subsequent question is literally like, how does the dispatcher find the coordinators? The initial plan is to do something like we do in service inventory, where basically the dispatcher will have a URL that can be a file or an HTTP URL, or really any URL that's handleable by the JVM, and it'll contain a list of coordinators and it'll be updated on the fly. Beyond that, like, we're just going to need input from more people on how that happens.
It's an important note, so that in this picture here, we have dispatcher in multiple clusters. The clusters are independent from each other.
Yeah.
And they'll each other on discovery.
So there's another question, which is, how about persisting the coordinator execution state? So I'm just going to go with, that's probably theoretically possible, but my guess is that it would take several years to actually write the code to do it. Presto is super asynchronous. It's why it's actually can run really low latent queries. So understanding you would basically have to rewrite the whole coordination process to, at every point a decision is being made, to actually record it into a durable store. So it would be a monster project and really complex. So our plan is basically to get to the point where you can have multiple coordinators and you end up having the equivalent of like a Hive job tracker, where it's like, yeah, if you lose a coordinator, you're going to lose the handful of queries that have been managed by that coordinator.
Yeah, also just to add, you could recover coordinator only as long as the data was not sent back to the client. Otherwise, you need to restart or renegotiate with the client. How do you proceed with partial results of the query?
Yeah. You also have the problem that if you lose a worker involved in the query, that you also lose the query. So it's not just how do I prevent coordinator failure, it's how do I recover from worker failure as well.
Well, with the ongoing projects around query resiliency, where they can be resilient to a single worker failing, like you could recover that in some cases. My actual real hope here is that like this is about reducing risk. So it's like once you can run multiple coordinators and they're doing a lot less resource intensive things, you're basically down to what are the odds that that you lose a piece of hardware that's acting as a coordinator. And when you do, you're going to lose N queries. Like, I guess the answer to that is it's so rare that assuming you haven't sent any data to the client, I guess you could just restart the entire execution. But even knowing that is a pretty tricky thing. Anyways, we look at all this as like a really long-term plan. So the basic idea is that we're going to iteratively get this better and better over time. What about, where was that?
Multiple dispatchers.
That's what I was mentioning at the end, was making dispatchers more highly available. So the only issue with running multiple dispatchers will be, well, I mean, there'll be a couple of issues, but the most complex will be making the queue durable. So probably the easiest model will be having a durable queue and a hot online failover. So you have a, what's that model?
Active passive.
Active passive, as opposed to active, which again, the dispatcher really doesn't do anything. So having an active passive isn't really a big waste of resources. Will it be possible to have multiple clusters each with multiple cores? Yeah, I didn't actually draw that picture. But yes, you can have multiple clusters with multiple coordinators when we get to the end of this. Having a dispatcher in place, will it provide rule-based dynamic routing of queries, and how will resource groups work? All right, so the first version, so resource groups, they'll be, that's what's actually in the queue, and the resource groups are driven the exact same way. Once a query is selected, once a query has reached the end of the queue, it goes into a phase called resource waiting, I think. And that's where the dispatcher is selecting a coordinator that's capable of running the query. Right now, that's just based on minimum worker count. And clearly there'll need to be more complex rules around that. But to start with, there's a phase where we can do coordinator fitting, and then it'll be dispatched after that. So will there be dynamic routing of queries? Maybe, if people want it. Like, there's actually a bigger question. There's a bigger design that we're not actually showing here, which is in the system we ran at Facebook, we actually had another box that's not shown here, which is a query router that we would have a system that kind of looked like this last picture here. And it was a gateway that would, based on the query, send it to the correct data center, and in the correct data center to the correct cluster to run it. So it'd be like, this needs to run in Iowa in an interactive cluster instead of a batch cluster. And then each one of those clusters would have its own resource queue because they're completely different things. So typically we've done we've done the routing in a separate process. So it's possible I could go into dispatcher, like just talk about it.
There's a Slack channel called Presto Gateway, where Lyft has open sourced their version of a gateway, and Uber is going to open source theirs as well. And then, so that's a good group to join if you're interested in that topic.
It will be possible to pick coordinators from among workers, even automatically.
What does that mean?
Well, it's can the workers be coordinators?
Yeah, exactly. So ideally, I would just set up something that is a central machine. Let's call it dispatcher. For now, till now, we used to call it coordinator, right? And then I attach like a bunch of machines that we used to call them workers. And I would like to this just work in a highly available way. So it would make sense even to, I imagine, pick up a coordinator for each query independently, something like that, so that each query can be coordinated by a different machine.
So that design is problematic in Presto for two reasons. The first is that workers, what they actually end up doing can be so resource intensive that you're unable to actually coordinate the execution, and therefore your query actually fails because the control messages aren't being sent. The second and probably bigger problem is that to actually coordinate work amongst workers, the coordinator has to be probing all the workers to see their current resource usage. And if you make every worker be a coordinator, then every worker is pinging every other worker for current resource usage. And that has to be a fairly high volume signal. So you'd end up just having every worker pounding on every other worker. So you end up with like this n squared messaging system. So it's better to just have designated coordinators.
Yeah, okay, thanks for explanation. But then you still could have some kind of automation around that, like you connect machines and some are designated as coordinator or multiple coordinators, and so that you could have like autopilot mode when you don't really need to assign role to each machine. I mean, in more advanced deployments, you would certainly assign roles to machines, and you would know which is which. But I'm thinking about something that works out of the box in a most easy way possible.
I completely agree. I actually think it's still too difficult to set up a Presto cluster. Like there are a bunch of things that I'd like to be more automated, like distribution of catalogs, internal communication credentials, security setups, a bunch of other things. So like absolutely agree. Like that would be great.
Yeah. I think we need a lot more discussion around like which of these features like we can put in Presto, and should these features need to be in like deployment specific like cloud automation stuff.
Yeah. Yeah, like is it a Kubernetes rule or is this a inside of Presto itself?
Right, or like what kind of hooks do we put in Presto to make the Kubernetes operator easier to write?
Will dispatcher include retry failed queries and load balancing work? So question is, will Presto include retry of failed queries and load aware balancing? So the retrying of failed queries is I think of it as an orthogonal project to what the dispatcher is doing. It's something, if we had that feature, it's a feature that would probably have to exist in the dispatcher because the dispatcher would need to be aware of what was actually going on with query coordination. And retry of failed queries is, I have like 10 ideas in my head just thinking about it. So it's a pretty big topic. We should probably talk about it later. And then load aware balancing. So it, I believe the first version has some load aware balancing. It tries to balance work amongst coordinators, but that will need to get better over time that's what I meant by coordinator fitting. So you have a query and like you need to select a coordinator that has enough workers and enough memory to run the query that you want to run. Right now, it's a fairly straightforward system. It'll need to get more powerful over time. Will it be possible to have 2+ coordinators and still have a single machine server as a cluster? Do you know what that means?
Well, there's the proxy, right? That would be the cluster perimeter if we wanted to, right? Do you want to talk about that, David?
Yeah, so we actually have a thing in Presto called Presto Proxy. It's a separate server that you can run. The idea is they're stateless. You can run as many of them as you need to based on load. You just put them behind a load balancer. And then you configure the proxy to point to either today a coordinator, in the future you point it at your dispatcher. And the proxy is secure. So the idea is that you can expose that to like your corporate network. So like your laptop running Tableau will talk to the proxy, and then the proxy will talk to all the backend Presto servers securely.
I'm aware. However, the proxy the proxy has some limitations as far as I know. For example, it doesn't handle the UI, only the query routing process, which is good and bad. So good because it provides like for complete isolation between users and the cluster, and bad if someone really wants to access the UI, because if you hide everything behind the proxy, then even administrator cannot access the UI. And second problem is that I'm not sure how the proxy, what the authentication methods proxy supports. Does it support all the authentication methods Presto server supports?
Yeah, today proxy only supports TLS client certificates because that's all we needed at the time.
Yeah.
And extending it, we could, but it's possible.
Yeah.
Yeah, because some
why it cannot support all the methods.
But I think what you're getting at is with dispatcher, the dispatcher can basically serve as like the single front end to your cluster, assuming you allow people to talk to it, because it's going to run the UI.
No, because clients need to talk to coordinators to once the query starts.
Correct.
Yeah, so I see this image, this image assumes that the client sends the query to the dispatcher, and at some point the client is informed about which coordinator will run the query, and then the client talks to this coordinator. And it is, I think this is the best general approach possible, because it removes dispatcher as a single point of every communication. And also this relates somehow to client protocol version 2 in the design phase, which there is an assumption that client will download data from workers directly if possible. So it makes a lot of sense because it removes single points and bottlenecks, but in some cases it complicates deployment, or it makes it harder to secure the communication. And in such cases, going through a machine that serves as a perimeter is makes the life simply easier. So it depends on the deployment and security model.
Yeah, the idea that I've been like thinking about, oh, we're over time, but just to follow up on this last one, is what I've been thinking about is that I think we're always going to need to have the concept of the proxy, which can terminate and be the single point for all communication. We're always going to need something like the gateway, which can do a routing of queries to dispatcher. We're always going to need something like a dispatcher, which can be the front end for multiple queries. Then for different environments, you're going to combine these in different ways. So there'll be environments like I absolutely can only have someone talking to the one master proxy, and everything else is hidden. So even if you're running the new protocol, HTTP, the new V2 protocol, which is still under design, where it would, theoretically download from workers, it would still go through a proxy that would then do that for you. And so you would combine these depending on what your exact security rules are, how complex your environment is, how much work you want to put into it. Because there's really no one size fits all for this problem.
Yeah, and I think in the topic of like, where does the UI run, and like, could you put the UI in the proxy, and like, could you do security around it? That there's definitely a lot of work to be done there.
Yeah,
we've got ideas, but it's the UI always started off as like something for administrators, and it like being able to expose it like directly to like end users on your corporate network. That might that's probably a huge amount of work.
Yep. So we're over time. Sorry about that. Didn't realize how late we're running. If you want to continue discussion, we'll be on Slack after this. And thanks for all the great questions. Really appreciate the feedback. Please let us know how this is working and any additional topics you want to cover in the future. The next meeting should be in about 2 weeks. Our guess. Yep. So anyways, we'll see you all on Slack. Thanks.